So please mute yourself if you're just coming in, and we will get started in just a moment. Thank you. So I just want to say welcome everybody, and apologies for the short delay. My Zoom was not cooperating with me this evening, but I finally have made it on and am excited to host all of you this evening. So I just want to say a warm welcome. I'm Deb McNamara with 350 Colorado, and I'm with the Renewable Energy Committee. And we are super excited to host tonight's webinar on heat pumps. And I'll introduce our main speaker here in just a moment. And I just want to say a huge thank you to everyone for being here tonight. Just a quick couple of rules, if you don't mind just keeping yourself on mute. And then you can chat any question, you can type any questions into the chat, and we will look to answer them at the end of the webinar this evening. So just to give you an outline of what's going to happen here. So we have Jessica Miller from Physicians for Social Responsibility. She's just going to share a super brief video with us and just remind us of the health reasons as to why we want to be switching away from natural gas in our homes. So we just wanted to provide that reminder. We think it's really important to get the word out about that. And then we'll be hearing from Neil Colway about heat pump water heaters. And I will introduce Neil more formally in just a few moments, but I just want to say thank you so much, Neil and Jessica, for joining. And I'm going to hand it over to Jessica Miller from Physicians for Social Responsibility, Colorado, just to introduce the topic. Go ahead, Jessica.
Hi, and good evening, everyone. So my name is Jessica Miller, and I'm a pediatrician in Durango, Colorado, and a volunteer with Physicians for Social Responsibility. And I've had the opportunity really over this past year to learn a fair amount about the health effects of us using gas in our homes with any kind of appliances, be it gas stoves, gas furnaces, gas water heaters. And so I'm really excited to hear more about what Neil has to say in terms of some healthy alternatives to that. As part of a program called Healthy Electric Homes this last year, Physicians for Social Responsibility created this short video that you're about to see, which really highlights some of the health impacts that using gas in our homes can have. So whenever we use gas in our homes, there's a number of byproducts that are produced: carbon monoxide, carbon dioxide, nitrogen dioxide, PM 2.5 molecules, and all of those things can have both respiratory effects as well as effects on many systems in our bodies. So I will let you guys show the video and then get on to Neil's presentation.
– 80% of the world's greenhouse gas emissions are caused by extracting and burning fossil fuels, which, despite its clean-sounding name, includes natural gas.
Oil and gas has done a marvelous job of taking a fossil fuel, which is methane, and calling it natural gas, and that goes into our homes.
While a lot of us think of how outdoor pollution affects things like asthma in children, a lot of people don't realize that burning gas indoors, whether it's through a stove or through a gas burning furnace, can also have effects on your asthma. A lot of times the level of particulates or pollution inside a house can be higher than outside.
The burning of gas in your home, in a stove, for example, open flame to the air, allows nitrogen dioxide and some level of carbon monoxide to accumulate in the home.
The carbon monoxide that is produced by, with gas appliances is the same toxin that comes out of the tailpipe of a gas car or a diesel car. We don't want to breathe that in, so why would we bring that into our house?
There are alternatives to burning fossil fuels in your home. Modern technology has made using electricity to cook with induction stoves, heat water, or heat and cool your entire home with heat pumps as affordable as gas. And with an all-electric home, there's no need for carbon monoxide detectors. Colorado law HB 20-1155B requires home builders to offer new home buyers the opportunity to have an efficient electrical heating system, including an electric water heater, electric boiler, or electric furnace or heat pump system.
Having gas in homes has both direct health impacts by the substances that are released into the indoor home environment, as well as more indirect health impacts of contributing to climate change over time.
Gas is dangerous and a known health impediment. If you are in a position to effect change, encouraging the use of electric cooking appliances, electric water heaters, electric dryers, and electric heating and cooling systems can potentially save someone's life and the Earth.
Thank you so much, Jessica. And hi again, this is Deb. Sorry, my video was not turned on yet earlier. So Jessica, thank you. And thank you for that video. I want to invite everybody to put any questions on the health impacts and the health side of this issue in the chat. And Jessica will be looking out for questions during this webinar too. So feel free to ask your questions. And thanks again, Jessica, for being here. So I'd like to pivot to introduce Neil, our main speaker for this evening, who will dive into a presentation on heat pump water heaters. And I just want to say thank you again, Neil, for joining us. And I'll offer an introduction. So Neil is the Industrial Program Director at the Southwest Energy Efficiency Project, also known as SWEEP, where he leads programs to advance energy efficiency in the industrial sector. Neil promotes best practices in utility energy efficiency programs for industrial customers throughout the region. Neil also promotes beneficial electrification in buildings and industry, working with the SWEEP Buildings team. So again, I just want to say a warm welcome to Neil and to everyone who's with us tonight, and we'll hand it over to Neil.
Thank you, Deb. All right, welcome everybody. I'm glad to be here to speak to you for a few minutes tonight. I'm going to talk a little bit about beneficial electrification, and then I'll get to heat pump water heaters and their benefits and a few challenges. What is beneficial electrification? Well, basically switching from fuel use to electricity in applications like heating our homes and cooking, as was just discussed, and heating water, and also transportation. And we call it beneficial, or some people call it strategic electrification, if it accomplishes one of these, at least one of these three benefits: reducing greenhouse gas emissions and other air pollutants, decreasing energy costs, or improving the utilization of grid resources, meaning like flattening out the load and making a more smooth load profile, and also improving the ability to add renewable resources to the grid. And why is it important? And hope you probably know this, but it's part of the three-pronged strategy for states and nations to achieve ambitious greenhouse gas goals. And as you probably know, most of the greenhouse gases come from using fossil fuels. There's a few other things like emissions from agriculture, process emissions from industry, etc. But anyway, so with regard to the energy, improving energy efficiency as much as possible is the first prong. It tends to be the most cost-effective way to reduce emissions. Secondly, reducing the carbon intensity of the electricity grid. And as the grid becomes cleaner, then it makes more and more sense to switch from fuel use to electricity. So a quick look at Colorado's greenhouse gas emissions. It's a bit busy here, but I want to draw your attention to the ones that are related to electrification. The 23% pinkish red pie is transportation. And as you know, electric vehicles are an important strategy. Fuel use in manufacturing is the 10% piece of the pie. And then the one we're mainly focusing on here is the 9% of Colorado's total emissions from fuel use in residential and commercial buildings. And so it's 9%. It's significant. And that's what we're talking about tonight. The Colorado Energy Office, also known as CO, and a consulting company they hired called GDS, did a study of the potential for beneficial electrification in buildings. And in their, what they called the high electrification scenario, which reminds me of a rock concert. In their high electrification scenario, 75% of the potential greenhouse gas reductions by 2030 would come from the residential sector, and 40% of those same savings are associated with heat pump water heaters. So it's important. That's a good chunk. And so that's why we're talking about heat pump water heaters. It's an important part of the strategy of electrification in buildings. What is a heat pump water heater? Well, here's a picture of one on the right. They are not that interesting to look at. They're just the same almost as any other water heater, but you can see the interesting red part on the top, which is where the heat pump unit is. So they're a little taller than regular water heaters. And basically what they do is they pull in the surrounding air. They use heat pump technology to heat the water, and in the process they cool the air around the water heater. So if it were in a heated space, it would add a bit to the heating energy consumption. And so I'm going to show a short video here. Hopefully you'll be able to hear this.
Neil, let us know if you've started the video or not. We don't hear it if you have started it.
Oh, I probably need to. Okay, let's try that again. Sorry.
That's okay.
Stated.
Sorry.
I think you need to share your other video screen too.
You can't hear that?
No, unfortunately
Okay.
not, Neil.
All right, it's not important. Sorry about that.
Actually, you know what? Maybe what we could do is share the link in the chat afterwards so folks can look at it after.
Okay, sorry about that.
No worries.
It was literally about 30 seconds long, and I think you got the gist of it. It's not rocket science. They also have electric heating elements as kind of a backup, or if the temperature for some reason drops below like 40 degrees, then they call that the hybrid mode. But basically, it's using the heat pump technology. They're very efficient, and that's what I'm going to talk about next. Some of the benefits. First of all, they're very efficient, so they use less energy than other types of water heaters. The way that we measure the efficiency of water heaters is with, it's called the Uniform Energy Factor, or UEF. So heat pump water heaters have a UEF of about 3.4, the good ones, Energy Star heat pump water heaters. And for an electric resistance water heater, the energy factor would be around 0.95. It means it's like 95% efficient. And for an Energy Star gas or propane water heater, the UEF would be about 0.68. So in other words, the heat pump water heater is about 5 times as efficient as the gas or propane one, and about 3.5 times as efficient as the electric resistant one. So you use a lot less energy. So one benefit of that is there will tend to be lower energy costs. So about 2/3 or 67% savings compared to electric resistance, 75% savings compared to a propane water heater. And because natural gas is very cheap, ends up being about the same cost as a natural gas water heater. And because it's using a lot less energy, there is also a lot lower net greenhouse gas emissions. As you know, when you're using electricity, there's still some emissions associated with that. Even if you have PV on your roof, you're using the grid for backup, and there's some fossil fuel use associated with that. But if you're not using the PV on the roof, and assuming the greening of the grid over the next 12 years, which is the average lifetime of a water heater, your emissions would be about 67% lower. For the heat pump water heater compared to electric resistance, about 60% lower than a propane water heater, and about 50% lower than a natural gas water heater. And to put that in perspective, for the case of the replacement of a natural gas water heater, the amount of emission reductions would be about equivalent to if let's say you drive a Subaru, oh God, my mind just went blank. What's the smaller Impreza? The Subaru Impreza gets about 30 miles to a gallon on average. And if you drove it about 2,000 miles less each year, that would be about the emission reductions you would get by using a heat pump water heater instead of a gas, that should say gas water heater, not gas furnace. So that gives you some idea. And now let's talk about the economics a bit. Heat pump water heaters do cost a bit more, about $800 more installed cost compared to a gas water heater. And it's maybe $700 more compared to propane, because propane water heaters are a little more expensive. Anyway, so compared to a propane water heater, even without any utility rebates, you will see a payback in about 2.3 years. So that's not too bad. You will see a payback in about 4 years compared to an electric resistance water heater. And of course, if there are utility rebates, it would be shorter than that. And if you happen to live in Boulder, you are in luck. Boulder has rebates of about $250 combined between Boulder City and the county, Boulder County. And beginning in June or July, Xcel will be beginning to offer rebates for heat pump water heaters, even if you're replacing gas, of about $500. So that would be combined of $750 rebate. And so you would basically break even if you are if you are replacing your gas water heater with a heat pump water heater. And you would have the greenhouse gas benefits that we discussed. But there's a few other challenges we should talk about. 4 things you need for a good installation. You need a temperature of at least 40 degrees Fahrenheit year round. So I've seen, people install water heaters in their unheated garage, so that's probably not going to work here. They do need a condensate drain. So you need a floor drain, an existing drain pipe, a utility sink, or or a sump pump. And for example, in my home, that would make it difficult because I have a crawl space, and I think I could install some kind of pump to pump the condensate and connect it with some sort of drain pipe, but that would add some additional cost. And you can't just drain it outside because in the winter it would freeze. So that could be an issue. You need enough space, and the picture shown here, you need ideally about 10 feet by 10 feet so that you could have good air circulation and can do the heating that you need from the surrounding air. But there's a way around it. Even in this picture here, they could install, this is not a heat pump water heater shown, but if it were, they could install some ducting through the door to provide the ventilation they need. But again, that would add a little bit to the cost. And then the last one here, the electrical panel, that's important. If you're replacing electric resistance water heater, then there's no problem. You already have 240 volts and plenty of capacity. In my home, it would not be a problem because I used to have an electric resistance stove and I replaced it with a gas one, sorry. And so I have extra capacity available. And for many existing homes, you would just have to look at your panel and do some math. And in most cases, you will have enough extra capacity that it wouldn't be an issue. But I'm going to talk about a new website in a minute, and we will have a calculator on our new website, which will allow people to do the math and decide whether they have enough capacity. And of course, you could also ask an electrician, or if it's a experienced heat pump water heater installer, they should know how to look at your panel and tell you whether you have enough capacity or not. And the point is, of course, if you don't, then there's going to be a significant cost in upgrading your electrical panel to provide the needed capacity. So that's helpful for maybe convincing some of you that you want to think about installing one in your home. But I wanted to talk a little bit about the bigger picture, like how do we see getting more heat pump water heaters installed to hit some of the goals I mentioned of reduced greenhouse gases. So we have 5 bullets here, which will help. First of all, we need to encourage utilities to increase their rebates. We did the best we could with Excel and we got them up to $500, but what we'd like to see, as I mentioned, is about $800 of the rebate to offset the incremental cost. And the ideal way to do it, the better way to do it, rather than making customers apply for the rebate after they buy the heat pump water heater, is to provide the incentive directly to the retailers like Lowe's or Home Depot. So the customer or the installer just buys the water heater and it's already the same price as the gas one. And another way to do the incentive is to give part of it, like $100 maybe, to the installer, and that gives the installer a better incentive to be interested in getting into the game of installing more heat pump water heaters. Secondly, with higher rebates, we need to get there's 3 main manufacturers of heat pump water heaters, Rheem, A.O. Smith, and Bradford White. And generally, there's not a lot of products available in Colorado, and so we need to work with them to convince them that things are happening here, and we want to see them start providing their products here. And a third aspect is, like we're doing today, educating people and landlords about the benefits of heat pump water heaters to get them more interested and start asking for them before you have a suddenly your water heater fails. and you call somebody and they say, well, all we have is these, traditional ones. So you need to plan ahead a bit, and it's part of the education piece. And educating the plumbers and installers, as I said, so that they're more interested, they know the challenges I just mentioned and how to get around them, and are pushing them more to people like, yeah, it's a good technology, it's very efficient, etc. And the last piece here is we would like to encourage new homes to be all electric. And there's a lot of benefits of all electric new homes. And we want to convince more developers and architects to go in that direction. And there's a few things going on. Sweep and a few others are working on some case studies of all electric new homes, try to point out they're not more expensive and they work great with, smart design. And we do have a fact sheet. I didn't put the link in here, but I can put it in the chat if you're interested. Sweep has developed a fact sheet on the benefits of all electric homes, including the health benefits that Jessica mentioned earlier. So then, related to the market development, I just wanted to mention a relatively new initiative, Beneficial Electrification League of Colorado, which we call BELCO. This is the logo for the National Beneficial Electrification League, shown here. It's a combined effort of several organizations, which I'll mention in a minute. And we're focused on these kind of market development things for heat pumps, heat pump water heaters, induction cooking. We're launching a new website, hopefully by March 1st, called energyrevolt.org. And it'll have a lot of resources for homeowners and contractors, others. For example, if you want to find out more about heat pumps or heat pump water heaters, we'll have answers to questions and how to find a qualified contractor, how to find utility rebates, and hopefully we think that will also drive more of the installers to want to be listed there, and so to want to get the training. And we're working on more training of heat pump and heat pump water heater installers. So the members include Colorado Energy Office, SWEEP, Tri-State and its member co-ops, Colorado Rural Electric Association, Energy Efficiency Business Coalition, and a couple of environmental nonprofits, Natural Resources Defense Council and Western Resource Advocates, and hopefully a few other utilities joining us soon. Our goal is basically to have kind of a unified message and approach and aligned beneficial electrification efforts across the state and improve the implementation of all these technologies, heat pumps, heat pump water heaters, induction cooking especially. There are other people focused on electric vehicles, so we're leaving that to others, and we're mainly focusing on the buildings part. So there you go. That's my speech, my presentation for tonight, and hopefully a few of you have some questions. Thank you.
Thank you so much, Neil. And Neil, you're welcome to either leave the slide up or, yeah, that's fine. You could, yeah. But Neil, if you wouldn't mind putting your contact info and any other links that you would like the group to have, you could put that in the chat at some point. That would be fantastic. So I just want to say thank you for the presentation. We do have a number of questions, and I'll jump right into those. I've been capturing them as they've come. And I just want to encourage folks to continue using the chat. And I will do my best to keep up with all of the questions. So let's start with one that I got via email earlier today from Sally. And the question is, heat pumps in the recent past operated by drilling underground. Now they seem to use an air exchange type system. Can you please explain the difference?
Yes, excellent question. There are still heat pumps being installed using the ground source technology, ground source heat pumps. It means, yes, you drill and you put pipes in the ground and run water through them, and then the heat is being transferred from the water using the heat pump technology. And so they're more efficient, but they're also a lot more expensive, or quite a bit more expensive. And the air source heat pump technology is like an air conditioner, and in the summer they're exactly the same as an air conditioner, and in the winter they're running in reverse. And so they're taking energy out of the air using the heat pump technology and transferring heat into the air of the inside of the house. And the technology of air source heat pumps has improved a lot over the last 5 to 10 years. And so now you can heat a house in Boulder or Denver. If it's a new home, you can easily do that with a air source heat pump, cold climate air source heat pump, without a backup furnace. And it used to be that the thinking was you needed a ground source heat pump if you wanted to do that without any backup. A few architects that I've spoken with recently are saying that, yeah, it's more cost effective to install an air source heat pump system. And so I hope that's helpful. That's a short answer.
Great, thank you. Thank you, Neil. So let's see. This is actually a call to action. We're recommending to Boulder City Council that prohibiting gas lines in our built environment needs to be added to this year's sustainability work plan. If you agree, please email Boulder City County. We love calls to action at 350 Colorado, so I just wanted to highlight that. And I can't recall who put that in the chat, but if you'd like to pop that call to action and any email address in the chat, please do. The next question is from Alvin. Is there information regarding how much of the bad stuff is produced based on how long and how intensely the appliances are used? And Neil, do you need clarification on that question?
Yeah.
Yeah, Alvin, if you want to unmute yourself and because it might have been. Go ahead.
Exactly a question for Jessica, who described the negative impacts in terms of particulates and nitrous oxides and carbon monoxide. It was just how much is produced relative to whatever health standards there are per unit of time of using a hot water heater or a gas stove. Is there any data on that?
Okay, thank you for clarifying. Jessica, are you able to share any further info for Alvin on that?
Yes, yeah, so great question. I can tell you, I think that there is some information on that. I haven't looked at those types of numbers directly, but just kind of thinking about the studies that I am aware of, looking at different health impacts. Certainly, time used is a factor, as is maintenance of gas appliances. So I'd say it probably varies significantly based on kind of like how well maintained, a gas furnace is or gas water heater, what the ventilation system is like, for a gas stove. And I think, unfortunately, those things are often things we don't tend to spend a ton of time thinking about, and I think most people are unlikely to follow the recommended maintenance frequency. So there's a good chance that levels of carbon dioxide, carbon monoxide, nitrogen dioxide that are released are going to be on the higher end if things are not maintained correctly or not hooked up to adequate ventilation.
Great. Thank you, Jessica. And I know we have a couple folks from PSR on the webinar tonight. If you all have anything else you want to share in terms of data, please feel free to put that in the chat. So the next question is, what percentage of the 9% is from commercial and what percentage is from residential fuel use? So Neil, that was from one of your early slides.
Yeah, good question. I think I couldn't exactly find that, but I'm going to say it's 2/3 from residential and 1/3 from commercial, something like that.
Okay, great. Thank you. Neil, can you talk about water cooling for radiant floors by chance?
You mean if you have a radiant heating system and you want to use it for cooling in the summer? I'd like to call on Dave Petroy to answer that question. He's out there. If you want to unmute yourself, Dave.
Sure. Yeah, hypothetically, you can do it. It's very difficult to do because you got to have a lot of condensation control. So it's extremely tricky to do. Let me just put it that way. And I have 10 years in ground source heat pump business and lots of radiant, and people ask us to do it. And I would recommend, if you want cooling, not to go that strategy, but look at air source mini split systems and figure out which rooms are really uncomfortable and what you don't like. And there's lots of nice indoor options with mini splits, and they're going to be more efficient. And that's a much better way to go.
Great. Thank you, Dave. And thanks, Dave, for connecting us with Neil and being part of planning this webinar. Okay, the next question is there an external unit for the water heater like there is with a heat pump heater?
No, it's all contained within the thing on the top of the water heater.
Okay, great. Thank you. And does the cost comparison with a natural gas water heater take into account the additional cost to heat the air that is cooled by the heat pump water heater?
Well, no, when I mentioned the installed cost, that's the installed cost. And so I did mention that, if it's in a heated space, you take a little hit on your heating cost, but the efficiency of the heat pump water heater is still what it is. So I guess it would, I guess what I would say is you would have to think about that. And maybe if you're using a gas furnace, for example, it would slightly increase your heating costs. I guess that's all I can say. And so if you're combining the two, then it would slightly take away from the benefits of the heat pump water heater. But if you're heating with gas, it's still challenging, as I said, to make it work. And you're basically taking a small hit on the initial cost and possibly on the annual heating cost, or it's about the same, as I said. But for the case of propane or electric resistance, you're still definitely coming out ahead.
Great, thank you, Neil. Okay, let's see. The next question is, what is the payback time versus gas water heaters?
Well, I tried to explain that if you have enough utility rebate that you're offsetting the initial cost, then you're basically breaking even. You're not really saving anything on your annual energy costs. It literally is about the same. So you're either paying a little more upfront or you're not, and you're not gonna. There's no payback period. So sorry about that. But you're doing it if you're doing it, unless you have solar PV and your electricity is much cheaper because of that, and then you could say your costs of heating with the heat pump water heater are less. Then there would be some payback.
Great, thank you, Neil. And I know I just want to acknowledge the time. I know we were aiming to have this be a short webinar because I know many folks are Zoom fatigued. We do have a couple more questions, and we are able to stay on for a few minutes after. So I just wanted to say that we'll do our best to get through the remaining questions. Okay, the next question is it a 110 or 220 hookup? That was from Bill. And I'm not sure, this may have been answered in your slides, Neil, but is there anything else you want to say about the kind of hookup?
Yeah, it's definitely 220 or 240 volts. And so that's one of the challenges. So that's why you need to look at your panel and see if you have the capacity. And yeah, it's definitely 240 volts.
Okay, great, thank you. So what can we do to educate installers? That's the next question. And the person who submitted this said about 2 years ago, I had to replace my hot water heater, and the installation company, Applewood, said I didn't have any non-gas options. And just to say, I hear this all the time from folks here at 350 Colorado that the installers don't seem to know about the options. So this person said, I've converted everything else in my house, gas boiler and stove. So this is the only gas left in my house. So do you have any insight on that? What we can be doing to educate installers on this issue?
Well, it's one of the things that Belco is working on, and we're starting with heat pump installations is even more challenging. If you have some skills, you can install a heat pump water heater yourself. And there's, if you go to YouTube, or I could share a link of installation tips from the Northwest. It's not rocket science, but it is one of the things that we'll be working on in conjunction with the utilities. It basically involves getting them interested and overcoming some of these challenges of thinking that that heat pump water heaters don't work that well, or just not understanding them. But once you look at it and think about it, it's really not that difficult.
Okay, great. Thank you. Thanks, Neil. So I know the questions have been coming in very steadily. If you all don't mind, let's hold on the questions. I'd like to get through the couple that we have left and make sure we don't run out of time. Neil has been so gracious as to stay a few extra minutes with us. I just want to say, in case folks do have to leave since it's 6:45, thank you so much for joining. You can always be in touch with any of us at 350 Colorado, and Neil and folks at Physicians for Social Responsibility are all available. So feel free to reach out if you have questions that didn't get answered. So again, thank you in case you have to hop off. And then let's see, the next question is, how do tankless water heaters fit in here?
Well, let's say you cannot do a heat pump water heater in your home because of one of the 4 issues that I mentioned. Then you could look at a tankless water heater as an alternative. Electric tankless is going to use a bit more juice. If you don't have solar PV, I wouldn't recommend it. And if you already have gas in your home, you could consider consider a gas tankless. They're a lot more efficient than the conventional gas water heaters with a tank. So I think I'll let it go at that.
Okay, great. Thank you. And thank you, Neil. I know the last webinar that we hosted with Dave, it was similar. We had a lot of technical rapid fire questions. So thank you for answering these. Okay, the next question is, how does the hot pump water heater coordinate if you also want to get a heat pump to heat and cool your home?
How do they coordinate? Well, they're separate, but if you're going to, towards the direction of decarbonizing and using as much electricity in your home as possible, then they work together fine. I don't know what to say about that. And in a new home, that's of course what you want to do. I don't know if any of you are having a new home built, but if you're going all electric, it's sort of obvious you want to use the heat pump system and you want to use the heat pump water heater, because that's definitely the most efficient way to heat the water if you're using electricity.
Okay, thank you. We had a couple questions about installers in the Boulder area. And so I'm wondering, Neil, if you could say anything about that. Are there recommendations? I know some folks were saying you can go to Energy Smart, but do you have any advice for folks wanting to get started?
I would definitely say call the Energy Smart people and ask them for the names of a few plumbers who have actually installed heat pump water heaters. And actually, I did this recently. I was working with a business downtown, and Ambra with Boulder County gave me some names of a few plumbers, and so I would just call the Energy Smart people.
Okay, great. So we have just about 5 more questions, and thanks everyone. I know there are probably more, but we can follow up offline with other questions that we didn't get to. The next question is, what maintenance is required and annual cost? Do you want to say anything further on that?
I honestly don't know. I don't think there's any significant maintenance issues with the heat pump water heater, and we already talked about the annual energy costs. So, it's like with your gas water heater, do you have any maintenance? I don't think so. You just, I mean, you might ask the heating contractor to come and look at your furnace every few years and tune the, if you have a gas furnace, tune the flame and everything. But I don't think there's anything that you do on the heat pump water heater or the gas water heater. Somebody else can chime in if I'm wrong about that.
Yeah, if anyone else has insight on that, please put that in the chat. Does a heat pump water heater recover as quickly as a gas water heater? Meaning, when someone takes a shower, how long does it take for the incoming water to heat up?
I haven't heard any complaints about that, but honestly, again, I'm not 100% sure, but I have not heard any people complain about quality of heat pump water heaters versus gas. I think it's the same.
Neil, Neil, I just mentioned all of them have 3 settings. There's like some electrical backup in there. And so if the full heat pump mode isn't good enough, you can knock it down one, which means it'll use a little bit of electrical to increase your recovery times.
Good one.
It's still going to be massively efficient and you won't even notice it. But, they do have that flexibility for users.
Great. That's a great point. Thank you so much.
Yeah, thank you both. Okay, you gave an example of a self-contained unit. What about split systems? For example, the Sandine CO2 type. Any comment for one or the other being better?
Are we talking about heat pump systems or heat pump water heaters? Whoever asked that question. I don't know about CO2 heat pump water heaters.
Yeah, I'm not sure. I'm just reading it how it was written. Is the person who asked the question still on? And what would you like to unmute and ask again?
Yeah, this is Kyle. They do make CO2 heat pump water heaters. And I saw someone in the chat gave an example where they had this Sandin unit installed from David. So, but yeah, just another option out there.
I bet they're expensive, and but I'm not familiar with them, so sorry.
Well, yeah, I know they're expensive, but just want to know if anyone had any insight.
Okay, if anyone else has any insight on that, please put any info in the chat. Okay, does the heat pump water heater need to exhaust the cold air it produces, or is it left in the house to be reheated by the outside heat pump?
Yes, you don't think about exhausting it outside. It's just heated by whatever kind of heating system you have.
Okay, great, thank you. And
It's
is the water
like, you know, when you have a refrigerator in your kitchen, and what's the refrigerator doing? It's putting out a little warm air. And so you could say, oh, in the summer, it's adding to the burden of my air conditioning system if you have one, or it's making my kitchen a little warmer if you don't have one. And it's you know, it's like that, only maybe a little bigger.
Okay, perfect. Thank you. Is the water maintained at a certain temperature?
Yes.
Okay. Great. I know, I love, yeah. Okay. And then does the 3.4 coefficient factor in the efficiency of the compressor? What is the efficiency of the compressor? And is the compressor usually a scroll pump? Sorry, I'm reading it just how it was written.
Oh boy, I have no idea.
Okay.
The 3.4 is the overall combined energy factor, and I don't know.
Okay, no worries. Okay, I think we just have
I can look into it.
One more question in the chat. Yeah, and I'm not sure who asked that question. If you are still on and you would like to correspond further with Neil on that, just put a note in the chat. There's just one more question from Scott in the chat, and then this will be our last question of the evening, and then we'll close. Can you tune them up to make sure everything is operating optimally rather than maintenance? Take a look during retro commissioning. Neil,
I think I'm sorry, I don't know what to say about that really. I mean, I think the commissioning thing is more of an issue for a heat pump system. Honestly, I think with a heat pump water heater, you just set it up and you make sure it's running right, and it's not rocket science. Definitely there's more challenges with installation of a heat pump system, and that's why the training piece is more important, and making sure it's properly installed or commissioned is really important. And I don't think it's as big a challenge for a heat pump water heater.
Would you want to be taking a look at things like making sure the drains are working well and the vents are not clogged and venting properly? Maybe take a look at that type of stuff every few, 5-10 years or whatever, 5 years, rather than looking for specific controls on the device.
Yeah, those are good questions. And I'm sorry, I can look into that and get back to you on that. I really honestly haven't looked into maintenance issues of heat pump water heaters. I'm sure what you're saying about the drain is true. You probably want to, make sure the drain is clear and everything. And if you have some ducting that you installed, you want to make sure that's clear. But in most cases, you probably don't have that. And so it's simpler.
Great. Well, I just want to say a huge thank you. I know we've gone a bit over, but we're still finishing before 7, which was our goal. So thank you so much, Neil. It was great to have you. I really appreciate your expertise. And like I said, we've been getting a lot of questions about heat pumps, so I'm glad we could offer this. And it has been recorded. I know there were a couple people that came late that asked if the beginning was recorded, and so we do have a recording. Let me know if you'd like that. So I just want to say thank you, Neil, and thank you, Jessica, and the couple of you from Physicians for Social Responsibility who joined tonight, and for all the work that you're doing just to keep the education forthcoming about why we need to make this transition, not only from a climate perspective, but also from a personal health perspective. So again, I just want to say thank you, everybody. Have a great evening, and please be in touch with any other questions, and have a great evening.
Thank you.
Take care. Bye, everyone.